Going. Welcome to Nutley Cisco Academy. We are doing modules 3 through 5 on network security. So, without further ado, don't forget to like and subscribe.
Did we start?
Yeah.
You got it.
Go.
Let's go. So, with networks, these are the current states of affair with network security. Cyber criminals have gained a lot more tools and experience, and this is this is now causing big important networks to be at risk. And now cyber criminals are taking malware at unprecedented levels and are making such big impacts on major corporations that network security is becoming the forefront of their uh, the forefront of what they're trying to accomplish because they need to protect their information because network security breaches can disrupt a ton of different things. So it's like it can make a business lose their data and can threaten people's privacy in their company. So they need to put protective walls in place in order to make sure that this doesn't happen. So vectors of network attacks. An attack vector is a path in which a threat actor can gain access to a server. So they mostly do that, and then once they get inside to a corporate network, they do a DDoS attack, which um, which occurs when a network device or application is incapacitated and no longer capable of supporting requests for legitimate users. This then uh, DDoS attacks are more prevalent to internal than external because it's a lot easier to do damage from inside a network than from outside a network. And internal users have direct access to the building and its infrastructure devices.
All right, so data loss is when data is intentionally or unintentionally lost, stolen, or leaked to the outside world. The data loss can result in brand damage and loss of reputation, loss of competitive advantage, loss of customers, loss of revenue, litigation/legal action, significant cost and effort to notify affected parties.
I'll tell you when you
And then common data loss vectors include email/social networking, unencrypted devices, cloud storage devices, removable media, hard copy, and improper access control. All right, so hacker is a common term used to describe a threat actor. Threat actor. Originally, the term referred to someone who was a skilled computer expert, such as a programmer, and a hack was a clever solution. So, type of hackers include white hat hackers, which are ethical hackers who use their programming skills for good, ethical, and legal purposes. White hat hackers may perform network penetration tests in an attempt to compromise networks and systems by using their knowledge of computer security systems to discover network vulnerabilities. Gray hat hackers. These are individuals who commit crimes and do arguably unethical things, but not for personal gain or to cause damage. And then black hat hackers are unethical criminals who compromise computer and network security for personal gain.
Evolution of hackers. Hacking started in the 1960s with phone phreaking or phreaking, which refers to using audio frequencies to manipulate phone systems. At that time, telephone switches used various tones to indicate different functions. Early hackers realized that by mimicking a tone while using a whistle, they could exploit the phone switches to make free long-distance calls. In the mid-1980s, computer dial-up modems were used to connect computers to networks. Hackers wrote war dialing programs which dialed each telephone number in a given area in search of computers. When a computer was found, password cracking programs were used to gain access. There are certain terms that there.
Are we going or not? I don't know if we're going or not. Okay, my bad.
There's a table that displays modern hacking terms and a brief description of each. Script kiddies are teenagers or inexperienced hackers running existing scripts, tools, and exploits to cause harm, but typically not for profit. Vulnerability broker. These are usually gray hat hackers who attempt to discover exploits and report them to vendors, sometimes for prizes or rewards. Hacktivists. These are gray hat hackers who publicly protest organizations or governments by posting articles, videos, leaking sensitive information, and performing network attacks. Cybercriminals. These are black hat hackers who are either self-employed or working for large cybercrime organizations. State-sponsored. These are either white or black hat hackers who steal government secrets, gather intelligence, and sabotage networks. Their targets are foreign governments, terrorist groups, and corporations. Most countries in the world participate to some degree in state-sponsored hacking. Cybercriminals. It is estimated that cybercriminals steal billions of dollars from consumers and businesses. Cybercriminals operate in an underground economy where they buy, sell, and trade attack toolkits, zero-day exploit code, botnet services, banking trojans, keyloggers, and much more. They also buy and sell the private information and intellectual property that they steal. Cybercriminals target small businesses and consumers, as well as large enterprises and entire industries.
Malware. End devices are particularly prone to malware attacks. It is important to know about malware because threat actors rely on users to install malware to help exploit the security gaps. Virus is the most common type of malware.
Trojan horses. A Trojan horse is a program that looks useful but also carries malicious code. Trojan horses are often provided with free online programs such as computer games. Unsuspecting users download and install the game along with the Trojan horse. Other types of malware. There's the adware. It disturbs by downloading online software. The ransomware denies user access to their files by encrypting their files and displaying a pop-up demanding ransom for a description key. The rootkit. Rootkits are used by threat actors to gain administrator level access to a computer. Spyware, similar to adware, but used to gather information about the user and send to threat actors without the user's consent. And a worm. A worm is a self-replicating program that propagates automatically without user actions by exploiting vulnerabilities in legitimate software.
Overview of network attacks. When malware is delivered and installed, the payload can be used to cause a variety of network-related attacks. To mitigate attacks, it is useful to understand the types of attacks. By categorizing network attacks, it is possible to address types of attacks rather than individual attacks. Networks are susceptible to the following types of attacks: reconnaissance attacks, access attacks, and DOS attacks.
An access control list, or an ACL, is a series of iOS commands that are used to filter packets based on information found in the packet header. By default, a router does not have an ACL configured. However, when an ACL is applied to an interface, the router performs the additional task of evaluating all network packets as they pass through the interface to determine if the packet can be forwarded. This process is called packet filtering.
Limited number of ACLs per interface. A router interface can have one outbound IPv4, one inbound IPv4, one inbound IPv6, one outbound IPv6. Numbered and named ACLs. ACLs numbered 1 to 99 or 1300 to 1999 are standard ACLs, while ACLs number 100 to 199 or 2000 to 2699 are extended ACLs. ACLs can be named to provide information about the purpose of the ACL. For example, naming an extended ACL FTP filter is far better than having a numbered ACL 100.
Where to place ACLs. The figure illustrates where standard and extended ACLs should be located in an enterprise network.
A wildcard mask is similar to a subnet mask in that it uses the ANDing process to identify which bits in an IPv4 address to match. However, they differ in the way that they match binary ones and zeros. Unlike a subnet mask in which binary 1 is equal to a match and binary 0 is not a match, in a wildcard mask, the reverse is true. Wildcard masks use the following rules to match binary 1s and zeros. A wildcard mask bit 0 will match the corresponding bit value in the address, and wildcard mask bit 1 will ignore the corresponding bit value in the address. Wildcard mask types. In this example, the wildcard mask is used to match a specific host IPv4 address. Assume ACL10 needs an ACE that only permits the host with IPv4 address 192.168.1.1. Recall that 0 equals a match and 1 equals ignore. To match a specific host IPv4 address, a wildcard mask consists of all zeros. A wildcard mask consisting of all zeros is required. The table lists in binary the host IPv4 address, the wildcard mask, and the permitted IPv4 address. The O.O.O.O wildcard mask stipulates that every bit must match exactly. Therefore, when the ACE is processed, the wildcard mask will permit only the 168.1.1 address. The resulting ACE in the ACL10 would be access list 10 permit 192.168.1.1 0.0.0.0. We already went over this.
How to create an ACL. Use a text editor and write out specifics of the policy to be implemented. Step 2, add the iOS configuration commands to establish those tasks. Step 3, include remarks to document the ACL. Step 4, copy and paste the commands onto the device. And finally, step 5, always thoroughly test an ACL to ensure that it correctly applies to the desired policy.
And these are our questions. Number 1, what are the 3 types of hackers? Number 2, what is the most common type of malware? And number 3, what is an ACL and what does it stand for?
Thank you, and don't forget to like and subscribe.
Thank you. Don't forget to like and subscribe.